Hello, so in today's video we're going to calculate the probability that a particle will be found between 0.49 and 0.51 L in a box of length L when n equals 1, noting that the wave function will be constant at this specific range. So over here we have the general solution of the Schrodinger's equation for a particle in a one-dimensional box. So I'm going to show you guys the way I would prefer to go about this problem, because when taking the integral of this wave function, it can get ugly due to everything that's happening in the sign. So we're going to just start by rewriting what we have over here. And we're going to rewrite it in this form. So when we take the integral of this, it's going to make our lives a lot easier. So A is basically representing the radical 2 over L. K is the constant, which is basically everything in front of the x. And we still have x over here. So whenever we're finding the probability of locating a particle, our domain is going to be 1.51 L, 0.49. And we always take psi squared dx. Now psi squared dx is going to remain the same as what we have over here. We don't have any i's or imaginary numbers, so it's going to be exactly the same squared. So we can go ahead and rewrite over here that our a, we're just squaring the wave function over our domain. We're going to have sine squared kx dx. Now it's important to note what this k value is in case we forget. K is going to be n pi over L, that constant over here. In this case, since n equals 1, our k is going to remain the same. So it's just going to be pi over L. So that's just an important side note to remember. Alright, so we could go ahead solving this equation. There's a trig function which is going to be 1 minus the integral of sine squared ax, or in this case kx, we'll just write it as ax dx, is going to equal the integral of 1 minus cosine 2ax over 2 dx. So this is just the common trig identity. So we're going to go ahead and rewrite our new integral, which is going to be p equals or 2 over L our domain. We're going to have 1 minus our cosine of 2kx over 2 dx. And remember, a is just a squared over here is basically the same. It's just going to be our 2L. Remember, we squared the square root, so now we just have 2 over L that we can pull out of the integral. So now the next step will be we can pull out the 1 over 2 that's over here, so we can further simplify what's inside of the integral. We'll have our, we'll have our 2 over L, and we'll pull out the 1 over 2, keeping our domain dx minus, again we can break up the integral because it's subtraction, the cosine 2kx dx over here. So we just simplified. So we pulled out the 1 over 2 from the integral over here. So you're able to just have 1 minus cosine 2kx. So now we have two integrals that are fairly simple to solve. So now we can go ahead with the next step. Now these 2's will cancel out over here. We'll have 1 over L outside of the integral. We'll have x. Again, we need to write our domains. So we know the derivative of 1 is going to be x minus our 1 over 2k sine 2kx. So remember, we're going to have to do the chain rule over here. So you pull out the 1 over 2k, and then the integral of cosine will be sine. And again, we're writing our domains. So now we can go ahead and substitute our domains into the x. So we'll have p equals 1 over L over 0.51 L minus 0.49 L minus our 1 over 2k. So again, these domains are getting plugged in into the x value. So we're going to have sine of 1.02 kL minus sine 0.98 kL. Now we can go back to the top, and we've established what our k equals. So we know k equals pi over L because n equals 1. So again, I'll write that over here. So now k equals pi over L. And what you see here is, I'll just do the scratch work over here, is sine, for example, 1.02. Our k is pi over L times the L. So our L's will cancel out. We'll just be left with sine of 1.02 pi. So, and vice versa for the sine of 0.98 kL. Whoops. Should write pi over L times L. This is going to give us just sine of 0.98. So we eliminate the k value over here by plugging in what our k is. So we need to keep in mind that we have a k over here. So we also need to apply what this k equals pi over L. So we have 2 pi over L, which we can just further simplify to L over 2 pi. So now we can go ahead and rewrite, simplify, and do the algebra. So we have 1 over L times 0.02 L minus L over 2 pi times the sine of 1.02 pi, which is 0.559, minus 0.0537. So we can go ahead and further do the math. We should have P equals, if we distribute the 1 over L here, we'll have 0.02 minus L over 2 pi. And then the 0.59 minus the 0.0537 will be 0.5053. And again, we can't forget that we should have distributed the 1 over L over here. So then this L and this L would cancel out, and we would just be left with 1 over 2 pi. So you can go ahead and continue on with the math. It's just going to be 0.02 minus